Hi ladies and gentlemen, we have made it to the last part of the trigonometry unit, and that is graphing sine and cosine waves. Before we get started, I would like you to please go ahead and do this warm-up. And for this warm-up, I would like you to please evaluate each of these without a calculator. So evaluate each of these expressions without a calculator. There are a total of 10 expressions that I'm going to write down for you, so you might want to make sure that you leave a little bit of space. The first one is going to be the sine of 0, so not theta, 0. The second one is the sine of pi over 2. The third one is the sine of pi. The fourth one is the sine of 3 pi over 2, and the fifth one is the sine of 2 pi. Then I would like you to please go ahead and do number 6 is going to be the cosine of 0. Number 7 is going to be the cosine of pi over 2. Number 8 is the cosine of pi. Number 9 is the cosine of 3 pi over 2. And number 10 is going to be the cosine of 2 pi. So go ahead and take a moment and evaluate each of these. Come up with an answer. Hopefully you've noticed like a pattern of the numbers that I selected for you to take the sine and cosine of. If not, that's fine. Hopefully it'll make sense in just a moment. So pause the video and evaluate each of these. All right, so hopefully for the sine of 0, you know that the answer to that is going to be 0. And the sine of pi over 2, you know, is 1. The sine of pi is equal to 0. The sine of 3 pi over 2 is negative 1. And the sine of 2 pi is 0. The cosine of 0 is 1. The cosine of pi over 2 is equal to 0. The cosine of pi is equal to negative 1. The cosine of 3 pi over 2 is 0, and the cosine of 2 pi is equal to 1. And what we just created, believe it or not, or what we just identified, are all of your quadrants going all the way around. So if we were to talk about 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi, those ordered pairs were located at 1, 0, up here was 0, 1, negative 1, 0, and 0, negative 1. So these values from our unit circle are actually the values that we're going to be working with whenever we graph sine and cosine waves. Whenever you took the sine of 0 and ended up getting the value of 0, what you just found is the first ordered pair of a sine wave. So what I'm going to do is, before I talk about the characteristics of a sine and cosine wave, I want to actually graph it for you. So what we have here is theta. You can use the value of x if you would like. You can write or x if that makes more sense to you. But if we were to take the sine of 0, the sine of 0, we know the answer of that is going to be 0. So our first point of the ordered pair for sine is going to be at 0, 0. Then we have pi over 2. So the sine of pi over 2, that was equal to 1. So I'm going to go over to pi over 2 and then up to 1, and here's my next point. Then we have sine of pi. The sine of pi, that is equal to 0. So at pi, I'm going to plot the point pi 0. Then we have 3 pi over 2. The sine of 3 pi over 2, that was equal to negative 1. So at 3 pi over 2, I'm going to go down to where negative 1 is. And then we have 2 pi. And at 2 pi, sine was 0. And what we just graphed here is one cycle of a cosine wave. And all cosine and sine waves are what we call periodic. And periodic means that these graphs continue forever and ever in the exact same pattern. So if we wanted to identify what the sine of negative pi over 2 is, well, we're just going to follow the pattern. So it's going to be at negative 1. And then the sine of negative pi, that's going to be up here at 0. Then the sine of negative 3 pi over 2, following the pattern, will be up here at 1. And then back down here at negative 2 pi. And we know that based on what we've seen so far, it's going to be continuing to decrease. And so here is our sine wave, and it will continue on forever and ever in the exact same pattern. So that is a sine wave. And now we'll talk about the amplitude, minimum and maximum, your period, in just a second. Now when it comes to cosine, we know that the cosine of 0, that is equal to 1. So I'm going to put 0, 1. So here's 0 up to 1. And then at cosine of pi over 2, that is 0. So at pi over 2, I'm going to go to 0. Then the cosine of pi is equal to negative 1. So I'm going to go down to negative 1. Then the cosine of 3 pi over 2, that's equal to 0. So I'm going to go back up to 0. And then the cosine of 2 pi, that is equal to 1. And here's what our cycle looks like. It's going to reach this maximum point and point right back down. Please be careful. Please make sure that your arrow is pointing down. Or in the correct direction. So that is something that's going to be very important. So continuing on with this pattern at negative pi over 2, cosine is going to be down here at 0. At negative pi, cosine is negative 1. At negative 3 pi over 2, cosine is 0. And then at negative 2 pi, cosine is positive 1. It reaches that maximum and goes right back down. So you have to make sure that you watch your end behavior. So what we just graphed here are a sine wave and a cosine wave. And there are lots of patterns for you to, in order to graph these very quickly. So for example, when it comes to a sine cycle, so one full cycle of a sine wave, we go 0, then up, then 0, then down, then 0 again. And so 0 up, 0 down, 0. So 0 up, 0 down, 0, up, 0 down, 0. And that's the pattern that it's going to be. 0 up, 0 down, 0. 0 up, 0 down, 0. And so that's going to be the pattern that you're going to see for sine. For cosine, we always start up, then 0, then down, then 0, then back up again. So it's up, 0, down, 0, up. So it's a little bit different, but it's up, 0, down, 0, up, 0, down, 0, up. And you keep repeating that over and over and over again. So that is the pattern for, a cosine wave. So, all right, let's go ahead and talk about some characteristics of sine and cosine waves. And then I will fill in a little bit more of this information. So the first thing that I want you guys to know when it comes to a cosine wave is that the domain of all of these functions is always going to be all real numbers. That is the domain. So there's no restriction on the domain whatsoever. The range for each of these functions is restricted. So it's going to be restricted based on your maximum value and your minimum value. But for the parent function, so we're talking about the parent functions of y equals sine of x or y equals cosine of x. And like I said, we use x and theta interchangeably. It's whatever floats your boat. It does not matter to me if you use x or theta, but these represent your parent functions. All right, so the range is restricted. The minimum value is -1. The maximum value is +1. So our range is going to be in between -1 and +1 every single time. Now this is just for the parent function. There's going to be other types of problems that we're going to be working with, but your range is going to be related to your amplitude. And we're going to talk about that in a couple of pages. So this is related to your amplitude. So whatever your maximum value is, so amplitude, very, very fancy terms, your amplitude of the graph is half the difference of the maximum value m and the minimum value little m. Or in other words, it's 1/2 times capital M minus little m. Or in a little bit easier format, the amplitude is equal to 1/2 times your max value minus your minimum value. But for our case, there's going to be like a number that's right in front of your sine and cosine waves. So like y is equal to like a times the sine of bx. That's where we're heading. And y equals the y equals a times the cosine of bx. Whatever a is represents your amplitude. I'm sorry, whatever a is it represents your amplitude. Sorry about that. So that's the number that's in front of sine and cosine. So in our parent function, there exists like an invisible 1 right in front of sine and cosine, and so therefore that represents your amplitude. So in this problem, for sine and cosine waves, notice that the amplitude for each is equal to 1. And that's because there's like an invisible 1 right in front of sine and cosine. So then the next thing that we have is each function is what we call periodic. And what periodic means is that the graph has a repeating pattern. It will repeat in that 0 up, 0 down, 0, or up, 0 down, 0 up pattern over and over and over again. The shortest repeating portion of the graph is what we call a cycle. So it's called a cycle. So 0 up, 0 down, 0 represents one cycle. Or up, 0 down, 0 up represents one cycle. And then that pattern repeats itself over and over again. The length, the horizontal length of each cycle is called a period. So the horizontal length of a cycle is called a period. And the sine and cosine graphs each have a period of 2 pi. That means we will start our pattern at 0 and it will end at 2 pi. We'll start our pattern at 0 down here and it will end at 2 pi. So up 0 down 0 up. And it takes 2 pi for it to complete one cycle. So that is what we consider the length. The x-intercepts of y equals sine of x occurs at 0, x equals 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, etc., etc., etc. And that's because the sine of 0 is equal to 0, the sine of pi is equal to 0, the sine of 2 pi equals 0, etc., etc., etc. So that represents all of your x values whenever you are working with increments of pi. The x-intercepts of cosine of x are going to be kind of the opposite. So what I mean by opposite is that instead of it being pi, 2 pi, 3 pi, 4 pi, 5 pi, etc., it's going to be pi over 2, or plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, plus or minus 7 pi over 2, etc., etc., etc. And that's because at every pi over 2, like where you can't simplify that fraction any further to be equal to pi or 2 pi, that's when cosine is equal to 0. So if we were to look at the cosine of pi over 2, that equals 0. The cosine of 3 pi over 2, that equals 0. The cosine of 5 pi over 2, that is also going to be equal to 0, etc., etc., etc. So the x-intercepts are going to be where you have a pi over 2, and you cannot simplify that fraction any further. So that's what we have down here. We have ourselves our period that's going to be at 2 pi for each. Your minimum value is going to be at -1, and your maximum value is at +1. And you can use that amplitude formula if you would like. The amplitude, once again, is equal to 1/2 times your maximum value minus your minimum value. And your amplitude, that's going to be equal to 1/2 times 1 plus 1 is 2. Half of 2 is equal to 1. Now this work you do not need to show. Essentially, you're going to be looking for A. Look for your A value. That's going to be the number that's in front of sine or cosine. Now your axis is going to be blank. And what your axis represents is the landing point. Where is your, how does your graph shift vertically, essentially? So in this case, our axis is going to be located at y = 0 for both of them. And I guess in a nutshell, this represents your horizontal axis, and this number right here is your k value. So what's going to happen is that in a couple of lessons, we're going to be learning about how to graph sine and cosine waves using A's, H's, and K's. And your K value is going to be whatever you're adding or subtracting at the very end. So eventually we're going to get to y is equal to A times the sine of bx, and then that's going to be minus h. So I think it's going to go like this. B times x minus h, and then you're going to have plus k. So that's where we're heading to. And this k value, whatever it is that you're adding on the outside, is going to represent your horizontal axis. So this is where, in this case, our horizontal axis is at y = 0, because at a parent function, we're not adding anything that we can genuinely see on the outside of that function. So the way that we graph your horizontal axis is it's always a dashed line. So in this case, it's going to be a dashed line located at y = 0. And for your test, I'm going to be requiring you guys to use some sort of color in order to show where your horizontal axis is. So I'm going to be using a highlighter of green. You're more than welcome to just use your pencil while you're taking notes today, but if you are a fan of color, I strongly recommend that you take out some color. All right, so this represents your sine and cosine waves. Now, I've already mentioned that, that you need to make sure that your arrows are pointing down, but I'm just going to say in general, when it comes to your arrows, watch your end behavior. That's going to be very important. A lot of students make the biggest errors on this test because they suddenly have this arrow that's pointing up, but which doesn't make any sense for the type of graph that we're graphing. So please make sure that you're careful with that. The other thing that I want you guys to know is this. When it comes to coming up with your ordered pairs for a sine and cosine wave, for sine waves, your first ordered pair is always going to be 0, 0, and for cosine, your ordered pair is always going to be 0, 1. And that's if we're talking about the parent function or something that is in the effect of like 0 and then your A value. But we'll get to that in a little bit, in just a little bit. Now, pi over 2, if we go back to our unit circle or creating our axes, pi over 2 represents 1/4 of going all the way around our unit circle. And then pi represents 1/2. So if we were to look at a unit circle, traveling around the unit circle, pi over 2 represents 1/4 of the unit circle. Pi represents half of the unit circle. 3 pi over 2 represents 1/4 of the unit circle. And 2 pi represents 1/2 of the unit circle. And so whenever we are coming up with our ordered pairs, the way that we are able to come up with our x values for the ordered pairs is this pi over 2 represents 1/4 times your period. And we're going to talk about how to find your period in just a second. So, or in this case, which our period, I'm talking about in general, if we wanted to figure out what our period is for any type of problem, we're going to be learning about a formula on the next page. But because our period is 2 pi, 1/4 of 2 pi, a fourth of the entire circle, is pi over 2. 1/2 of 2 pi is equal to pi. 3/4 of the entire circle, unit circle, is equal to 3 pi over 2. And then your final answer is going to be 1/2. So 1 times your period. And that is true for all of your x values of the ordered pairs. So down here we have 0, 1, and then pi over 2 represents a fourth of the circle, and then half of the circle, and then 3/4 of the circle, and then 1/2. And so that's a pattern that I want you guys to please make sure that you know and you recognize and that you understand. So now let's go ahead and flip the page. And let's talk a little bit more about sine and cosine waves. Now, there's going to be questions on your test that will be based off of this table. So the table that I'm about to create, I need you guys to please make sure that you know and study this table. I'm going to put a bunch of stars around this table because I need you guys to please make sure that you study it and you understand it. So example number 1 says, tell whether each statement describes a characteristic of a sine function, cosine function, both of the functions, or neither of the functions. So for letter A, it says the function has an amplitude of 1. Now, an amplitude of 1 occurred in both functions. They both had an amplitude of 1. They both reached 1 each time. So they both had that amplitude of 1. The next one, it says the function passes through the ordered pair 0, 0. Well, since cosine starts at 0, 1, it's not going to be cosine. Sine is the one that starts at 0, 0, and so it's going to be sine. Cosine goes through the ordered pair 0, 1, so it's not going to be cosine. The function increases on the interval of 0 is less than or equal to theta, which is less than or equal to pi over 2. So we want the function to be increasing or going up between 0 and pi over 2. So looking at 0 to pi over 2, I'm going to look at my first function right here. This is a sine wave. And make it clearer for you. Hopefully it comes up. Here we go. So going in between 0 and pi over 2, the sine wave is increasing. It's going up. It would have a positive slope right here in between these 2 points. Versus cosine, going from 0 to pi over 2, it is decreasing. So the answer in that case would be sine. So a problem that might be on your test might give you a different interval and asking you, or saying that the function is increasing or decreasing. So in this case, the answer is sine. The next one, the period is pi. Well, we know for sine as well as cosine, the period is actually 2 pi. So in this case, this is going to be a neither. For both sine and cosine, the period is 2 pi for the parent function. The next one says it has an axis of y equals 0. Well, we just graphed that axis on both of them. So in that case, they both have an axis of y equals 0. Then the next one says the horizontal intercepts occur at multiples of pi. So that means multiples of pi are 0 pi, pi, 2 pi, 3 pi, etc. The horizontal intercepts, so that means your x-intercepts. And your x-intercepts occurring at pi, or 0 pi, pi, 2 pi, and 3 pi, well, that's sine once again, because all of your x-intercepts would occur at increments of pi over 2's, essentially, for cosine. So in this case, it's sine again. This one is a little bit of a trick, so I want you guys to keep that in mind. It says the horizontal intercepts occur at multiples of pi over 2. Well, multiples of pi over 2 is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, etc. And at 2 pi over 2, that's pi, and 4 pi over 2, that's 2 pi. So in this case, it's both, because the x-intercepts happen at pi over 2 and 3 pi over 2 for cosine, and 2 pi and, pi and 2 pi for sine. So in this case, this is actually a trick. So kind of look for things like that to occur. The next one says that the range of the function has been between 0 and 1, and unfortunately that is not the case for either one of these. The range of the function for each of these is -1 is less than or equal to y, which is less than or equal to 1. Your minimum value is -1, not 0, so that is a neither situation. The maximum value of the function occurs at multiples of 2 pi. Okay, so multiples of 2 pi, that means that we're talking about 2 pi, 4 pi, 6 pi, etc. So I'm going to look, I know that my x-intercepts for sine are located at 2 pi, 4 pi, 6 pi, etc. So I'm leaning towards sine, or cosine. And if you were to look at -2 pi, it's at 1. And then here is 0, it's at 1. And then we have 2 pi, it's located at 1. So the answer in that case would be cosine. So cosine has a maximum value at multiples of 2 pi. Then we have the minimum value of the function is -1. And that is true for both functions. The minimum value is -1. And the function decreases on the interval of 0 is in between, pi is in between, theta is in between 0 and pi. So let's go ahead and look at that. In between 0 and pi, it is decreasing. So here is going from 0 to pi, cosine is decreasing, versus 0 to pi, sine is increasing then decreasing, and we want overall just decreasing. So that is going to be cosine. So like I said, please make sure that you feel comfortable filling out a table like this, because once again, there's going to be questions similar to what you see here, where you'll have to analyze the parent function. So this all pertains to the parent functions of sine and cosine. So that's what I just wrote up here. These are the parent functions, analysis, characteristics of the parent functions of sine and cosine waves. So now what we're going to do is we're going to talk about amplitude, or change in amplitude. Now A denotes a change in amplitude, and there's that little A value that I said that would occur. It's the number that you're multiplying in front of sine of x and cosine of x. And the amplitude is like a vertical stretch of the graph. It affects your maximum and your minimum values. So that's going to be your A value. That will represent your amplitude. Your change in your period, the letter B. So we're now going to be looking at y equals the sine of B times x, or y equals cosine of B times x. The B value helps us to determine the change in the period. So B is not necessarily a period, but it helps us to identify how our period changes. And a change in the period, what that means is it describes the change of how fast the graph moves through a cycle. So that's what I'm going to talk about here. It's the changes, or the change of how fast the graph moves through a cycle. So since a normal period is 2 pi, in order to find the period, what we're going to do is we're going to use the formula 2 pi divided by the absolute value of B. So that's what we're going to be working with. This formula right here, 1 period is equal to 2 pi divided by the absolute value of B. That is the formula to identify a period. And since our normal critical values are at every pi over 2, We'll divide pi over 2 by b in order to come up with our new increments. Only use this statement right here if you are struggling. So only use this if you are struggling to come up with the x values. But the trick that I'm about to show you when it comes to coming up with your x values I think is a little bit easier. So only use if you are struggling with your x values. All right, so what we're going to be doing is we're going to graph trigonometric functions in the form of y equals a times b, a times the sine of bx, and y equals a times the cosine of bx. Now the first thing you do whenever you graph these types of functions is you need to get the coordinates from your parent function or your parent trigonometric functions of y equals sine of x and y equals cosine of x. Then you're going to be using your b value to determine the period and the increments to use in your x-axis. So what I mean by that is this. I want you guys to go ahead and draw these two tables. We're going to call this x, and this is going to be y. X and then y. So what we're going to do in order to graph in the form of y equals a times the sine of bx and y equals a times the cosine of bx is in order for you to come up with your x values for the sine of x, we're going to come up with new x values. So these are going to be new x values. And in order to come up with your new x values, we always start with, for sine, 0, 0. So this will always be your ordered pair that you start with when it comes to sine. So this is y equals a times the sine of bx. Then remember that 1/4, 1/2, 3/4, 1. What we're going to do is we're going to multiply 1/4 times your period. And your period formula is 2 pi divided by the absolute value of b. And then we're going to have 1/2 times 2 pi divided by the absolute value of b. Then we're going to multiply 3/4 times 2 pi divided by the absolute value of b. And then we're going to multiply 1 times 2 pi divided by the absolute value of b. Your y values are going to be 0 up, 0 down, 0. So 0 up, you're going to go all the way up to your maximum value, and your maximum value is what we call A. That's like your amplitude. This is going to represent your maximum value. 0 up, 0. We're going to go back to 0, then down to your minimum value, and that's going to be negative A. This represents your minimum value. Then back up to 0. So 0 up, 0 down, 0. That is your ordered pair every single time that you're working with y equals a times the sine of bx. And that's what you see here, 0 up, 0 down, 0. And then we just keep repeating that pattern. And this works for y equals a times the sine of bx. So I know that this is kind of hard to read, but that is a times the sine of bx. So now we're on to cosine. So in order for you to come up with your new x values, we're going to do the exact same thing. So your new x values for cosine is going to be this. We always start with 0, 1, or your 0a. Because remember that cosine starts up, because it's up 0, down 0, up. So we're going to start at 0a, and a once again represents your maximum value. So 0a is where you start. Then your x values we're going to be working with that 1/4, 1/2, 3/4, and 1. And we're multiplying those fractions by your period. So that is 1/4 times 2 pi divided by the absolute value of b. 1/2 times 2 pi divided by the absolute value of b. 3/4 times 2 pi divided by the absolute value of b. And then 1 times 2 pi divided by the absolute value of b. And then remember, we go up 0, down 0, up. So up at our maximum value, 0, down to negative a, this is your minimum value, 0, then back up again to A, and that's going to be your maximum value once again. So up 0, down 0, up, and that's going to be your pattern every single time that you graph y is equal to A times the cosine of x. I'm going to stop this video right here, and I'm going to start up the next video, and that's going to be all of the graphs that you'll be doing. For this next video, there's going to be a lot of your turns that I want you to pause the video and then check to see if your answer is correct. You can fast forward through a few of the examples, especially if you got the answer correct at the end. So like I said, I'm going to stop the video right here, and this is a lesson that will have 2 videos.